Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com. And today we're going, I'm laughing because I wanted to say, and later we'll be talking to Carl Fife. But first, this is Telestax, and we've got some really, really interesting people with us, and hopefully they will figure out how to unmute by the time I introduce them. But for the moment, I'm just going to tell you that this is VUC 525. We're going to be talking about Restcomm plus OpenBTS. We probably should actually introduce the company. And somebody's got a phone call, so you go ahead and take that at your leisure. Ivelin, I'm going to call on you, and you can introduce the company, and if you'd like, introduce the folks that are with us, and whatever else introductory that you have to do.
Big happy to. Thanks, Randy. I was starting on a upbeat.
Welcome back.
Thanks for having me back. Yeah, so I'll reintroduce the company for the folks that have not seen one of our sessions here. Telestax has been around for 3 years now. It's based on the MobiSense open source community projects for telephony applications. And Restcomm is our flagship product. It's a telephony app platform that targets mainstream developers, and I'd rather show than tell from here on out. This demo webinar session is going to be about something really exciting and breakthrough in the industry that a few people in the know are aware of, but not enough, and way too many more should be aware of. The folks at Range Networks who support the OpenBTS project have done something truly amazing. They've been able to do what a lot of companies have done for enterprise software. They've been able to build antennas, base stations on their open source projects that bring the accessibility, the price of these antennas for GSM networks to an incredibly affordable level. And we have Bob Fools, who's product manager from Range, with us here to help me out with any questions that are on the hardware antenna science side.
Welcome, Bob.
Thank you. I'll certainly do my best to answer the questions.
Go ahead, Ivelin.
All right. So let me dive into it without further ado. So I have two regular Android phones, pretty low-end devices, and they have SIM cards that have registered with a Range Networks OpenBTS antenna. So let me share my screen for a moment so I can show what these Android phones are connecting to. Here. All right, this is the image of the box. It's in the it's in the other office here next to me. So let me go to the management console of the device. So it looks like if I'm going to be managing a local Wi-Fi router, only it's not a Wi-Fi router, but it's a GSM antenna. Pretty exciting. So any regular GSM phone with a SIM card can connect to it and call each other, send messages. So let me just do that first. Let me just do a quick call and a quick message exchange, and then I'll go into what actually is happening. And pardon my voice, it's a horrible allergy season right here in Austin. It's been raining, it's been cold. Hopefully.
By the way, the things that we're talking about right now, people can go to Restcomm, restcomm.com, and under the products, I think they will find what they're looking for, correct?
That's correct. Thank you, Andy.
Okay. We need to remember to say that a couple of times during this.
Okay. And that's our open source project. It's kind of the top of the Marbusend's pyramid of open source projects. And we'll talk more about what it is here. So, right, opening one of the phones, making a call to a number, and the number I'm calling to is 2001. It's actual a number that the other phone is registered with the base station. Normally these phones will be dialing a full PSTN number, but because I have a local setup of a full telecom network, I can assign whatever numbers I want to these phones. All right. Let me share the screen. Oh, the phone is going through.
Incidentally, while you're doing this, I'm leaving the little opening slate that we created up, just so that people can have a little view of what the little device is, because it's a small little desktop device that you're using, and you're accessing its. I presume you're accessing its administration functions now.
That's correct. Okay. So what's flying through in the console is the communication between the two phones calling each other, going through the through Restcomm and through the base station. So let me answer and turn on the speaker on one phone and speak. So I'll turn back to my screen here. Okay, so there are two phones connected, talking to one, hearing the speaker of the other. Okay, that was one quick demo. The next thing I'm going to do is send a little message, a text message, saying hi, very creative message. There's this message screen on the other phone is cleared, so we should see a text message arrive. Okay, there it is. You probably heard it. I don't know if you can see well, but it shows one new message just arrived. Mm-hmm. And it's a very exciting hi message. Get excited, guys, come on. All right. So let's go into the what happened under the hood with this quick demo. Nothing really special happened, except that these phones were not registered with AT&T or T-Mobile or Verizon or any of the traditional mobile operators that you would expect phones with SIM cards to connect to. If you can see this, typically the phones here at the bottom would show the network they're registered with. Let me find the camera. Okay, and
it says Rest. Okay, the screen's gone out, but it said Restcomm for a short while.
Right, that's exactly what I'm trying to show. It says Restcomm versus AT&T or T-Mobile, and the reason why that is because I have the programmatic access to the full stack, from the antennas, the base stations, to the backend application servers, etc. All right, I'm sharing my screen again to show you what I'm doing with that base station. And as I said earlier, it looks like if I'm configuring a Wi-Fi router with a local access, see the 192.168.122, the boxes on my local network, and it has a management UI. It has parameters that some of them I don't understand. I'll talk about the ones that I do understand. Here's a short name of the telecom name. I picked Restcomm accidentally. and that's why the phones show Restcomm when they register with the GSM network. Now the next side of the screen, the configuration area, is the part where the base station. This is a true innovation from Range Networks and the OpenBTS community. What's happening here is traditionally the GSM base stations, they speak an obscure SS7 protocol language with the rest of the core GSM network. What OpenBTS does is that it represents each of the mobile devices as a SIP endpoint. So any SIP server can see these phones as soon as they are turned on and registered. They'll be seen as if they're regular SIP extensions, just as if they're office phones connected to a local PBX. Not very, conceptually very similar. Okay, so the upper part of this configuration page here shows that when the base station gets a signal from a phone, whether it's a new phone registering with a base station, or this point here, or it's a phone tries to send a message, or tries to make a voice call. In all these cases, the base station would route a SIP call to whatever address and ports of a SIP server are there. And in this case, I've provided the address and port of Restcomm, which in my setup here, in my home office, are essentially, Restcomm is essentially a SIP registrar that keeps a database of registered phones. It's also an SMS server, and it's a voice server as well. All three of these things. So earlier on, when I tried to make a call from one phone to the other, what happened in essence is one phone connected over GSM standard protocol. It's been around for 30, 40 years, however many years, connected to the base station, and this smart box converted that signal into SIP, connected to Restcomm, and the same happened with when the other phone registered. So when I initiated the call, Restcomm just saw one SIP client calling another SIP client and routed the call. Pretty basic. And same thing for SMS. Same idea. Now, that already is pretty amazing, pretty breakthrough from my point of view, because all this is open source stuff, with maybe the exception of the hardware devices, but they're running Android, and they're generic Android devices. The box that the base station box from Range Networks also runs their open source stack. So no magic here, no, everything is transparent. All right, so let me pause and see if there are any questions before I continue.
I have a question.
Yes.
I think it might be worthwhile looking at. I have to do a little switch here. I think it would be worthwhile looking at who does what and how this fits together. In other words, I know that in the United States, when you want to be connected to the internet, you find out that you need to have a phone line and you need to talk to, say, AT&T or whoever. Then you need somebody else to provide the internet. In other words, there are different people, different companies involved. Now, we know that there's hardware, which is from Range Networks, correct? And so,
yeah.
Can we get the overhead view of who the different people? What do you need if you're going to do this tomorrow? What do I have to order? What libraries do I have to look at? How do you fit in that picture, and how does Range Networks fit in that picture?
And what licensing do you need?
And what licensing do you need?
In those
I think I know.
How do you keep the black vans from pulling up outside your office?
All right,
Yeah.
so you have Carl Fife quintuple
with the straight jackets.
You have a quintuple question from 3 different people. I'm sure you can handle it.
Yeah, easy, I think, not a problem. I'll just delegate to Bob. No. All right, so first off, the main pieces are the devices, generic devices, Android phones in this case. Could have been iPhones, could have been Nokia phones, whatever, with SIM cards. They come from off the shelf. In this case, it's a BLU manufacturer somewhere in China. I don't know. Bob can tell you where these devices come from.
We're talking. You're talking
through manufacturer.
I'm sorry. What radio bands? And then whoever else I just spoke over. Who was that trying to talk?
That was Bob.
I'm sorry, Bob. A quick question on the frequencies, because that's a problem in different countries.
Yeah, absolutely. So spectrum usage is regulated by governments around the world, and different governments have different regimes. The GSM system, which Ivelin is showing, can operate in any of the standard GSM bands, 850, 900, 1800, or 1900. And you, in order to use these in any kind of a environment, you have to conform to whatever your country's regulatory standards are. So in order to actually offer this as a service, you would, for commercial purposes, you'd obviously have to have access to spectrum to be able to do that. Interestingly, in a couple of countries, Netherlands and Sweden, they've actually unlicensed part of their 1800 megahertz spectrum. And you don't need anybody's permission to go in and offer service there as long as you stay in that spectrum. In a lot of the customers that we have around the world, these systems go into places where there are no other carriers. And, again, you have to conform to spectrum, but it wouldn't surprise me if somebody was operating something that everybody just kind of winks at. There's a real push here to get communications in the hands of as many people as possible, and entrepreneurs will find a way to meet that market need if there's a demand.
Is there a way to operate, say, in guard bands in the United States? Is that like legitimate? I know that mobile network operators will give you little femtocells that operate, as I understand, in guard bands. But I'm wondering if that's something that they can do because they own the spectrum, or if they're essentially, in a very narrow band that is in fact, if low enough power, et cetera, et cetera. Is that something like can I run a small network, in my home or in my office or something like that? You know what I mean?
So in the United States, the way that you deal with this is a little bit. We could spend the entire hour in spectrum policy. I don't want to do that because I know Ivelin has other things that he wants to talk about. But basically, in the U.S., for research purposes, laboratories, that sort of thing, you can go to the FCC and get what's called an experimental license. I can send out information if someone's interested in that. Typically, you'd ask for an experimental license in the 900 or 1800 megahertz bands because those are the ones that aren't being used for commercial service in the United States. And there are slices of spectrum in there that the FCC will allow you to use. If you wanted to offer something in the U.S. in the 850 or 1900 band, you would have to get permission from one of the carriers that own that spectrum and work with them basically to allow you to have spectrum. Now, there's also spectrum coming up here in about a year and a half that Google's been pushing, band 42. It's a 3.4 to 3.6 gigahertz band. That won't be unlicensed, but it will be lightly licensed enough that enterprises will be able to basically buy or acquire rights to spectrum in their facilities and be able to operate their own networks inside of that band. That will most likely be an LTE/VoLTE type implementation. And in an industrialized world, you'll see more of that going on. in other developing countries, areas where there isn't a lot of communications available, GSM or UMTS is many times more economical.
Yep, very, very interesting.
And just to reinforce what Ivelin was saying, there's no deep insight here other than what because a lot of the people involved in Range Networks are from the VoIP world. We basically just said, look, the air interface belongs to 3GPP, and the core belongs to the internet. And once you marry those two concepts together, and in effect disaggregate the 3GPP core down to a few very simple protocols like SIP and WebRTC and the like, you can really change the simplicity and the manner in which you construct wireless networks. You don't have to have complex cores. You don't have to have complex processors and specialized software and expensive licenses. If you have a SIP, as Ivelin did in a matter of days, if you have a SIP agent or proxy or registrar or what have you, you can be up and running with this in a very, very short period of time.
Right. Yep, that creates a lot of very interesting application possibilities. That the relevance of everything that's going to be said for the rest of this call, in my opinion, hinges upon that. Unless you're one of the very few people who are going to go into the wireless business, at least in the U.S. That's not practical if you live, in.
Let me shed a little bit of color, I guess, on this same topic with numbers, with economics. So in countries where emerging market countries where the average subscriber cannot afford to pay the bills that AT&T would charge their postpaid subscriber in the US, their mobile operators that are profitable at charging $3 per month per subscriber. Compare that to the
rural areas, or these in urban areas, or are you not collecting that distinction?
Yeah, let's not make the distinction immediately. The point I'm trying to make is that mobile networks can operate at that cost, almost 50 times, 20 to 50 times lower cost than what is currently the perception of the cost for operating them in the US. I mean, Europe is not too far off. Actually, Europe is still cheaper than the US, but the multiple factors matter, but the level of technology implementation is one of those huge factors. So the current coverage I'm displaying a third-party source of coverage for networks. So if you look at the AT&T coverage, it's pretty decent. It's far from 100% though. There's still huge open areas around the country. And now if it currently costs AT&T a few million to cover a radius of 10-15 miles, with a product from Range Networks, they will be paying a fraction of that, literally. And Bob can speak to maybe better to these ratios, but it's ridiculously how different it has become with what OpenBTS has achieved with support from Range. So now we have AT&T with reasonable coverage and Verizon, and then you pick anybody else. Look at T-Mobile. What is this, like 30%? It's a joke. Pick somebody else, it disappears. So if current operators with technology immediately available today by Range OpenBTS, they can cover the country so much better and can be so much more competitive. I went with my family to Taos, New Mexico. Sorry?
Oh, I was going to say, so the costs you're describing are the cost for the base station,
Yes.
the e-node, but there are also other costs like physical towers and cavity filters and antennas, things like that. How much of the total cost of operating an e-node comes down to those non-modulation, radio modulation components?
Bob, can
Like
you
those
speak to that?
modulators are very expensive. I just don't know how much that factors into the total cost. When you're operating, if you're operating in an emerging market, I think that the cost for real estate and labor and logistics and unions and all that stuff is considerably lower. But I'm wondering, like, is this a market disruptor for wireless operators in the United States, or is it that the actual radio frequency modulator, component of it and the software, integration component of it that I believe is what we're talking about here, that those components, I wonder how much those are, what percentage of the total cost of operating a network that represents. So even though it's a lot, if you're talking about I can or I cannot afford to install an e-node, for a mobile operator like AT&T, is this a significant cost?
That's a very good question.
Yeah, no, it's a good thing to talk about. I think there's a number of practical considerations here, and I appreciate Ivelin's the kind words. The reality is that an AT&T or T-Mobile, Sprint, or Verizon wouldn't come within 10 miles of us as a supplier at this point. We're a small company, and their infrastructure requirements, just from a bureaucracy point of view, would basically crush the staff that we have. So the targets that we have as a company are really oriented towards enterprise customers in North America, and a lot of the developed world, because the macro cell networks out there operate on completely different economics. But within the enterprise themselves, being able to have a private voice network similar to what they have with Wi-Fi for data is a compelling argument. For the developing world, or for areas where there aren't a lot of macro networks already in place, then the economics become better. Certainly the level to which you build the network it will determine a lot of the economics around the antenna, the power amps, that sort of thing. What we've tried to do is keep it very, very simple and very low cost. You can certainly build hardware using OpenBTS that's much more expensive, but the kind of thing that we're working with hardware suppliers on, and what we've done is proof of concept, is really oriented towards getting the hardware cost down into the few $1,000 range, and still be able to operate on a service range anywhere, depending on terrain and all the rest of it, of anywhere from a few kilometers to 10 to 15 kilometers. So it becomes more of a question of what can you afford to deploy in order to get service. And Range just isn't going to be a supplier to the major networks here anytime soon.
Bob, is there such a metric
That's
as
the question I was thinking more about, like the macro trend. Is this going to be an industry disruptor in the course of the next 5 years? The software radio, open stack type of concept.
Well, certainly the major. I mean, you also have a bit of a cartel going on here in the suppliers too, and between the big four suppliers and the big networks, and then the regulators, there's kind of this circle that goes on. What I would say is more interesting about what we're trying to disrupt is definitely on the air interface side, but also on the core side, because when you look at the amount of money that goes into your MMEs, your S gateways, all the fancy protocols that are defined, these are all completely unnecessary, particularly in a VoIP world, to be able to deliver good quality service to customers. And so we believe though this is a multi-year process because, as you know, communication networks don't change overnight. We believe that in more industrialized countries that we will affect deployment starting more with inside of enterprises, specialty applications, companies that need private networks, and the like, and then from there expand out. We don't believe that it's going to happen through the majors, but we do think that the open source is definitely of interest. We know, for example, AT&T and Verizon both have initiatives to uncouple processing power from their vendors' proprietary hardware platforms and put that onto, Linux, high-powered Linux devices and that sort of thing. So I think the trends are definitely moving in that direction. But as you know, in telecom, it takes years to build up the momentum on that.
Yeah, I totally understand. And in your case, your scenario of enterprise that want to run private networks, I would put myself in that category. Is this the kind of thing that you would implement, with a like a single eNode or multiple things? Or are you doing things like a distributed antenna system so that you can have very low power and therefore not be disruptive, on the air interface? Or how is that? How do you envision that?
Yeah, that's a good question. So from a physical hardware point of view, we certainly can support DAS. We kind of have an inclination though towards something more like mobile access points, small warts that you install in a enterprise on the ceiling like you do with Wi-Fi. In a reasonable size enterprise, 50 to 100 people, you're probably looking at, again, depending on their configuration, their building, but it's probably somewhere around 4 to 6 these small access points, very low power, typically operating 100, 200 milliwatts, that sort of thing.
I see. So just like Ethernet drops from a PoE switch, that kind of.
Yeah, absolutely. Yeah, back. I mean, it's basically a CRAN for the enterprise, right? Because you're backhauling your signal processing back to a Linux server, and your access point is basically just doing the signal collection.
Yeah.
So can I clarify that? Just out of curiosity, so are you suggesting that you wouldn't even put any kind of local DSP power in the wall wart? You'd route pretty much the whole output of the SDR down an Ethernet and have a Linux box with several VMs running in a cupboard somewhere. Is that the model?
Yeah. Hey Tim, good to see you again.
Hi. Yeah. Hi.
That you definitely can do that. You could put the processing if you wanted into the access point, but you can also run a CRAN. One of the other trends that is happening in the mobile industry is in fact CRAN, where you're basically backhauling the signal processing to a co-location. In macro networks, that's done over high-speed fiber, but in an enterprise, you can easily do that over Ethernet.
Right. Thanks. Cool.
If you can do SAN over Ethernet, I imagine that similar.
Oh my God, we have silence. So
that's only because I'm looking up CRAN.
Carl. So do we need
Cloud RAN?
Are we continuing here, or who's taking it?
I can continue. This is Ivelin.
Okay.
I really like to. I mean, I know Bob is being realistic and humble, but I really like to put big economic numbers that catch people's attention, that also are realistic. And I pulled up a presentation by one of our customers, a Brazilian telecom with a little over 1 million subscribers. So what they did is replaced Huawei and Ericsson equipment over 3 years with projects based on MobiSense. in the core network, and they came out publicly said, okay, we saved 15 million over 3 years by doing that. A tiny telecom with 1 million subscribers. That, I think, is the kind of ratio, the level of impact that the work that Range is doing with OpenBTS can and will have on the hardware antenna side. All right, I'll continue with the original talk.
Yeah, sorry.
Are there questions here?
Before
No.
sorry, before we leave the topic of the CRAN, I just looked that up. I didn't understand what that was, but it's a centralized radio access network. So does the software kind of does OpenBTS or your approach to this make it easier to do CRAN than it does if you're sort of using legacy equipment? I mean, the reason I ask is because right next to us in Chicago downtown, I think it was, I can't remember who it was that spent the money. I think it might have been AT&T. They spent something like $8 million putting a DAS into the Aon Center, which is that iconic, sometimes called the Amoco building. Looks like the World Trade Center used to look in downtown Chicago. And so so they spent $6 million on a DAS, and I'm thinking to myself, wow, that if that type of application could have been deployed as a CRAN, it would have been a lot less expensive, I would think. So I'm wondering.
Yeah, there's definitely a
edge. Go ahead.
There's definitely the architectural battle between DAS and sort of more of a access point approach. DAS kind of represents the big iron, approach to things. Yes, you could have done it as a cloud RAN, basically, where you're backhauling everything. But the AT&Ts of the world, the big companies, while they have some initiatives in this area, as a big company, they also have their own schizophrenia. One part does DAS, and the other part's looking at more cloud RAN access points, that sort of thing. So big company's going to pursue everything, and right now I think for these big buildings, these big venues, that sort of thing, DAS seems to have the majority of the installations at this point. But again, we're not going after that kind of. I mean, I'm speaking for Range here now. We aren't going after that kind of installation, really huge buildings. Our mission right now is to install things in enterprises and small buildings that support somewhere between 50 and 200 to 300 people.
I had to step out for a second there, but has anyone mentioned the Dutch experience, where there are hospitals and people like that who run these kinds of networks? I mean, not actually on OpenBTS actually, but they have local licenses to run their own GSM, and they do this actually because Vodafone had a countrywide fault for about 4 days. And the hospitals took the view that they couldn't support that as a process, so they had their responsibility to run that network themselves, which I thought was fascinating. So there are several that do that. I'll try and dig out some names and maybe put them in the chat in a minute.
Yeah, Tim, I think that's a really good point. Again, Netherlands has a very progressive spectrum policy in that they've allowed a portion of the upper 5 megahertz in the 1800 band to be completely unlicensed, which opens the market up for innovation like what that hospital was doing. I don't know of specific companies, obviously, in Netherlands or Sweden, but I do know that there have been installations like that for that reason. We wish that kind of thing would expand to other countries, including the United States, but at this point in time, that's only Sweden, Netherlands have that unlicensed approach. UK has a 3 megahertz band, I think in upper 1800 that they sublicensed to 12 or 13 companies, low power operation some time ago. That's another possibility to do this kind of thing as well.
So which chat are people in? Are they in the Hangout chat or in IRC?
It'd be more IRC.
Okay, I'll put it in there.
Anyway, so I do want to, I mean, one of the things that we were very excited about is what Ivelin was able to do with Restcomm. At the end of the day, the access point we kind of view more as a utility. It's the application software that companies like Restcomm bring to the table that really provide the services that customers use. So I want to make sure Ivelin has a chance to talk about the really neat stuff that he's doing, because that's where we think a lot of the innovation is going to happen.
All right, back to me then. So until now, we talked a little bit about the impact on building or rebuilding mobile networks in a lot more effective way, challenging the status quo and redoing things so that they're a lot more cost effective and make a lot more sense in a modern world. What I want to transition now is that the consequence that has on advancing the industry. Because now that we've been able to move to new infrastructure, to new paradigms, new programming models, not only have we addressed the cost issue, but we've also addressed the issue of stagnancy of the industry, of essentially every telecom selling the exact same product for 100 years. Voice, text, done. Maybe USSD here and there. And let me show rather than talk more. Okay, so this is the, again, if you notice, the address that I'm going to with the browser is the exact same address as the local address, as the one that is running the base station admin UI. So in other words, Restcomm in its full capacity is running on the base station right now. But that base station is smart. It's connected to the internet. So we'll see what that means. Okay. We've talked about Restcomm and what it can do in previous sessions. I'm not going to drill into a lot of details. But let me say that on this instance, I registered a local number, 411. Let's call it my telecom 411 service. And I assigned to it a very basic application. I just place something. And let me call that with my phone right now. Call, speaker.
Visual Designer demo.
Did you guys hear anything?
Yes.
Yeah, we heard.
Yeah, we heard.
So it was a very basic prompt, just a simple app that I did. And which is the app? Let's go and take a quick look at it. I think it's this one. It did nothing more than just text-to-speech, certain text. That was it. Okay. Let's move on. What else can I do with this now that I have the system set up? How about a conference server? All right, let me implement a conference server. So I built this extension, assigned 555 local extension, and I built a quick conferencing app. Let me open that. It's extremely complex and sophisticated. I'm not sure if you'll be able to understand it. It plays a prompt and it joins a conference, 2 steps. So let me call that app now. 555 on this phone. Speaker on.
And conference room.
Okay. So one phone join the conference. If I call the same number with the other phone, they'll be both in a conference and they can talk to each other. So conference service for mobile phones, for mobile phone network, Takes minutes to build. Okay, so now that's nice, and it demonstrates that there's this visual powerful tool that you can use to create all kinds of custom services for this custom mobile network, which could be actually an extension to any mobile network. But what's next? Well, what's next is that since it's so easy to build these apps, it's also not very hard to publish apps in the App Store, in the Restcomm App Store. So this little conference call that I built, I'm probably not going to sell it because it's so trivial. But if I wanted to, I can export and start offering it on the Restcomm App Store. So if I'm an enterprise or mobile operator that runs a network and I want to be able to sell added value services or use some kind of interesting telephony integration services for my employees, like CRM integration, I can build it and with this tooling, or I can do something faster and simpler. Go to this menu and look at what apps are already made available by the community of developers out there that I can just use immediately. So here the list goes, page mount and so on. I've earlier on I installed this app, voicemail to email. You can look at it in the actual App Store online, apps.restcomm.com. It's a basic shopping experience like any other app in any other app store. There's instructions how to install it, set it up, test your app, and once I download it, I drag it in here, it's deployed, I can go configure it. And in this case, the configuration options are pretty straightforward because the app is simple. It simply records a voice message and sends it over email. Which email will receive it, from subjects, etc. And I can look at the app design. Well, it's a little bit more sophisticated. A couple of modules. It prompts, records a message, and it makes a connection to an external web service. So even though this Restcomm instance runs on this box in the next room, it actually is connected to the internet, so it can use an outside service to send a voice message recorded by one of these Android phones over to my Gmail. And let's try that out. So I've assigned extension, I think 1001, was it? Yeah, right here. There's a voicemail service. So let me test that real quick.
To leave a message for support, press 1. For sales and general inquiries, please leave your message and phone number after the beep and press star when you are finished.
Hello, recording a really good message during the VOC webinar. Let's see if that works.
Thank you for calling.
Okay. So I left the message and let's see if it shows up in my mailbox here in a minute or so. Control S. All right, but I need to drag my Gmail window over here. Okay. All right, so here it is. Let's see if it plays. Well, recording a really good message. VOC webinar. Okay, did you guys hear the playback or not?
Yeah.
Yeah, I heard it.
Okay. All right, so this was more of a 360 demo. this base station is smart enough, runs Restcomm. It can install an app from the App Store that anybody built. It's internet connected. The voice message was recorded from the phone on the box, but then it was shipped over email. And played.
There's a couple of questions for Range Networks on IRC, and I'm going to ask Tim to ask them because I think he knows what what they mean, whereas I don't.
Good grief! I'm still reading them right now. But so starting from the bottom, there's a question about how you do charging. So does it do do you support standard diameter charging, or do you run something like one of the other charging interfaces? How would you bill for these calls if you were running it in? I mean, I think we're thinking of a kind of third world instance, or maybe like a shopping mall or something like that, where you actually want to charge people somehow or do some kind of billing.
Yeah, so there's all sorts of different ways of doing billing, but if you wanted to do a usage-based billing, the system does generate CDRs, which you can import into anything that you want. We actually have one service provider that had developed their own very simple billing program, and they just imported these into a CSV file and do some manual calculations and produce their bills that way. When you start talking about lower end type service providers, they're not going to be investing huge amounts of money in Amdocs or other high-end billing systems, that's for sure. Within the enterprise market, we're not necessarily sure that people are going to do billing. That is, it's provided as a facility for their employees and visitors, just like Wi-Fi is when that's installed. So I think different markets will have different approaches to the process.
More just to kind of finish off on the diameter thought while I think about it. Does Telestax support diameter? Can somebody from Telestax tell me if diameter is a module that you kind of support in general?
Yes, we do. Telestax is behind the most popular open source diameter project, JDiameter.
So at least in principle, somebody could add that feature of doing billing via diameter. It's just not being done.
Oh, correct. Sure. Yeah.
Okay. Sorry, I cut you off, Bob. Do continue.
Oh, no, absolutely. It's a question of how much time and effort people want to put into their billing process that drives a lot of that, and that's usually customer by customer dependent.
Okay, so I'm just going to scroll back and see if there's anything else that I can find here.
There was a question about how Open Nodeb. What is that?
Open Node B. I have no idea. That's new to me. So somebody can tell me.
What is Open Node B, Bob or John?
Well, so they're probably referring to the 3G project that we just added to OpenBTS. A couple, 3 months ago, we uploaded to our public site in GitHub the initial release 99 implementation, data implementation for 3G, and definitely have a program underway to continue to enhance that.
It's funny. I'm watching Linux Geek responding on IRC, and he's obviously watching the YouTube video, and it's like about half a minute behind. So it's kind of interesting to watch him kind of say thanks to something that presumably was like a minute ago. But anyway, that's cool. Kind of latency in the system here.
Well, I have an extension question.
On the Node B portion, the 3G portion, you can just go to GitHub, download the software, get yourself a Edis Research SDR, and you can be up and running with a 3G implementation as well.
He's asking how far along it is. I don't know what kind of answer you can give to that. But,
well, yeah, it's the release 99 data. So it's the UMTS data that operates at 800 kilobits per second download, and I think it's 416 uploads, something like that. That's not HSPA.
Okay. Did we cover all the questions? No, Andy.
Yeah. I just wanted to carry on a bit with the billing side of it. If we're in a situation where you are billing, and Linux Geek is suggesting it's the sort of thing that he might like to drop into the middle of Iraq and connect to it by a satellite, how are people actually authenticated onto this? How do you control the authentication? So do people just roam on randomly? Can they just roam on? Or?
Well, that's a good question, Andy. It really depends on how you want to set it up. So you can, OpenBTS does have a mode which, basically you can allow anybody on and essentially ignore, all authentication issues. And in certain circumstances, that may be a good thing to do. Disaster recovery, a snap network type implementation, that kind of thing. If you're in a more formal environment where you want to control who comes onto the network, then there's a gateway process in OpenBTS, the commercial version. This is not in the public version at this point. That allows you to send a message to a gateway provider of map services, and from there be able to query back to the home HLR to get the authentication vectors to be able to do the authentication locally.
So you are supporting traditional authentication methods as well?
Well, we don't do it. Again, everything we do is IP, so we send a SIP message to a gateway that basically converts to map and handles it from there. Yeah. And of course, the conversion could equally go to diameter. It doesn't really matter. We personally believe that the protocols of the future need to be more around IP-based protocols that are much simpler to use, and we would even like to see getting into a REST implementation for this kind of thing.
Well, I know Telestax certainly likes to support some of those things. It's a discussion that we've been having with Jean a few times of late. So yes, that's good. Thank you.
There is another question, which is, I'm trying to look up now, Blade RF, but where's that question?
Yes, Blade RF is another SDR company that we know and like, and their Blade RF implementation, I think it's the X40 and X115, both operate OpenBTS as well. So there's a number of companies out there that are really trying to drive the economics of radio heads down, and the company name is actually Nuon, but the product name is Blade RF, and we think that they're absolutely on the right path.
So actually, I finally found his question, which was any plans to support Blade RF? I guess from your answer, yes.
Yeah, it's already, I mean, the Blade RF folks already have OpenBTS running on their product line. I don't think they've got the 3G version working quite yet, but they definitely have the 2G version working, and absolutely, I mean, we think that Blade RF has a very good value proposition trying to bring the cost of these radio heads down, and we fully support what they're doing.
Well, this is like speaking Chinese to me, but I am going to read. He says OpenBTS support. He, by the way, it might be G for all I know. OpenBTS supports it. Wants to know if Open eNode B will support it too.
Yeah, that's the 3G implementation. You know, unfortunately, I don't think it's quite there yet. I know that that's something that they've been working on, but I don't think it's quite done yet.
Okay. All right, and we're getting up to the hour mark too here. First of all, if anybody's got any questions, it's time to maybe type them into IRC or jump on.
I actually have a question for Bob.
Call on Carl in just a moment, but go ahead. Go ahead.
Okay. We talked a lot about the enterprise with OpenBTS, and we see that there is a huge market with Internet of Things as well. So I was wondering what were the plans for the IoT and machine-to-machine type of market for OpenBTS, and if it was a market you were looking at.
Yeah, we are. and we do think that this has a great deal of applicability in IoT. I've spent close to 20 years in the Internet of Things, back even before they called it that. And the one big thing that I noticed about using the traditional cellular networks is they're very rigid in how you can interoperate with them. And the applications in IoT really don't, they really need to have something that's a lot more flexible. And so we do think that, software like from Telestax and OpenBTS could have a major impact in IoT applications, probably starting with, again, private networks, smaller networks, or dedicated bandwidth type networks, and then expanding out from there as spectrum becomes more readily available. Certainly things like white space implementation for IoT we think makes a lot of sense.
Thanks. That does make a lot of sense to me as well.
And we have a question.
For me?
No, not yet.
Oh, sorry.
Okay. Is it my question?
Yeah.
Oh, okay, thank you. All right. Since I already admitted, and I'll readmit that I know nothing about hardware, but I've heard about another project that does something similar to base station called Osmocom. Can I ask Bob to talk about the two projects, like how they complement or compete with each other?
Yeah, Osmocom is a project focused on 2G. There has been some code that I think has gone back and forth between the two open source projects. It's a we think that the notion of bringing additional ways of doing base stations to the marketplace is overall very good for the industry. I think when it comes down to particular issues around, when customers actually start deploying it and how it's going to be supported and enhanced and the rest of it, I think there's where you have to have a flexible open source model, and I think we'll see those models evolve over the next few years as customers make their wishes known and as companies like Range Networks respond to them.
Gotcha. Thanks, Bob. So the two projects kind of borrow code from each other, and they also innovate in their own ways.
Yes, absolutely.
I think, I don't know if it's implied in that answer, or maybe it needs a little more, but Osmocom's thinking is to try and implement a full classic network, SS7 style network stack. So they sort of stick to the existing model that most telcos implement, but they implement it in open source and in innovative ways. Whereas the Range stuff, the plan is to move to SIP as early as in the process as possible, and not necessarily to do all of the other classic network behavior that's specified in the 3GP documents or the GSMA documents. So there's a sort of philosophical difference between the two. One is trying to implement effectively the GSMA standards, kind of full stack but in open source, and the other one is trying to say, well, actually we're basically IETF, but we happen to have a radio on the front. So it's a sort of philosophical difference there as well, and which one suits you depends on actually your philosophy of life as well, I suspect.
Thanks, Jim. That helps.
Fair enough.
Do you think that just like some countries are going to move to that, they skip the whole wired telephone paradigm and are just mobile because there's no good reason to have poles and stuff and it's not convenient, that SIP isn't SIP going to be someday, you can start this, Tim, if you want, isn't SIP going to someday be completely useless and not a step that you need to go through? I mean, it already seems a little old hat to me.
Yeah. I think put it this way, it's a huge improvement over the full GSM. For a small implementation, in a supermarket, shopping mall, hospital, whatever. The full, 3GP design of something that's designed to run 100 million phones over a continent doesn't really scale down very well to a hospital. I mean, this is what the thing we found on, you find when you try and deliver this to an island with 1,000 people or something, that you have a whole series of boxes, each of which is basically doing nothing, but you have to have them because that's what the architecture specifies. So I think SIP is a huge improvement over that. Whether in the long term you'll end up actually just doing effectively something kind of WebRTC-like and doing peer-to-peer calls and really having very little infrastructure in between is, well, if James was here, he'd say you've got to do the billing somewhere.
Yeah.
And you've got to do the call recording and legal intercept and put your voicemail somewhere. And I think he's wrong, actually. I think you do that in the client. But, I hear the argument.
Well, Tim, I think there's going to be some of that will be required. How that needs to be done, I think, is still open for discussion. I mean, as you know from our previous conversations, we're very much on the road to more WebRTC-like implementations, and so we've kind of cast our lot in that regard. But that's consistent with Range's philosophical approach anyway, which is to isolate the 3GPP standards basically to the air interface and open innovation up behind that. What ultimately wins, I think it's anybody's guess, but we want to be able to foster that innovation.
Okay, we're moving into conclusion territory here, I think. I know we have one more question from Carl, but before we do,
of course,
let's make sure that, and I've been pronouncing it is it Evelyn or Ivelin? All these years.
Getting so much better, Andy. You're getting so much better.
Tell me, is it Evelyn or Ivelin?
Evelyn.
That's what I thought. So I'm better. Okay.
Yep.
Anyway, what do we need to say before we get Carl in here? Because once we let Carl loose, all bets are off. So, did we get to the conclusion of?
Yes, I think we did a full circle of what we wanted to accomplish here. Demonstrated it's possible to run regular networks with regular phones. With all open source stacks, and not only replace legacy stuff but innovate with new applications. It's a bigger topic. We can take it to another webinar. Talk more about new things.
Well, I'll talk to you via email about that within a week or two. Okay, so here's a feature that we love at the VUC, and let me introduce it thusly.
And now here's one final question from Carl Fife. Although the words one and final are not contractual. So here's Carl Fife with a series of questions and sub-questions that may or may not be possible to answer. Take it away, Carl.
Oh, thank you, Alison. And again, yeah, nice shirt. So my question isn't that great this time. I really, it kind of harkens back to what you were saying earlier about mobile networks for IoT. I'm curious about that as a concept, because it seems like an unusual networking technology to use for IoT, because the cost of a cellular transceiver is pretty high, and it seems like the IoT is all about having transceivers low cost enough that you can put them in your in your $2 widget, right? So do you have any thoughts about that?
I definitely do. I'm not sure who else wants to take the question, but I do have my own comments.
Go for it.
Okay, I'll go for it. So that was my original impression, but after doing some research, what it turns out, we've done demos of similar demos with for IoT recently, and we've been obviously on the Web User Conference a couple of months ago doing that kind of demo with Electric Imp. And what we found out is that for a Wi-Fi connected device, the per unit costs are about $100. At scale, we were told it drops down to $10, $15. And then guess what? You can get a generic Android phone with camera and USB connection and NFC and everything, all of that, for $20 nowadays.
Really? That's
I
pretty
mean,
expensive.
the economy of scale of Android
That's right.
are crazy.
That's true. Although for things to, I mean, for $20 doesn't seem like very much from a consumer perspective. But if you're talking about adding that to the cost of your device, I mean, some of the devices we make, we sort of throw up our hands because we can't make them for less than 6 cents, right? So, so the point is that, like, I think that $20 is still pretty large, and it would certainly hold whole categories of applications at bay. I think you'd have to have a pretty, robust, revenue model to support, that kind of feature addition. Like, I mean, like City of Chicago, I know they have recently changed their coin-operated parking meter systems to a very high-tech, very low, very poorly conceived, in my opinion, system of purchasing, parking using these little appliances that are all over the place. You buy a ticket, stick in your window. It's gotten better, but whatever. The point is that those things use cellular backhaul to do credit card processing. That's a nice application of IoT, but even that application, you've got a machine that does nothing but receive money for a living. So you can see how they might be able to justify the cost of a $20 radio in a device that probably costs $500 and basically prints money. Right?
Carl, I think the topic there is definitely one that's worthy of a session in itself. I mean, from our perspective, I'd like you to think of OpenBTS as more of a philosophy and concept. That is, if we wanted to implement a different protocol, and there are several IoT protocols out there, in software, you could basically do the same thing, and you probably, depending on the frequency you're using, you could probably even multiplex the signals off the same radio and simply separate them in software back where the signal processing is taking place. So if you start looking at how you're going to get IoT networks, specialty IoT networks, out on a macro scale, you could take advantage of that kind of technology as well. I still think initially, at least for what we're trying to do, we're probably going to see more private network type implementations just on the bands that we have available. But longer term, I think if we break beyond the confines of 3GPP thinking into what you're talking about, I think we're going to come up with a lot of different ways of being able to process radio signals economically to be able to support really inexpensive devices.
I think that the other thing you have to bear in mind, Carl, is that is spectrum. If you've got parking meters spread out over 10 square miles or something, it's really, really difficult to get allocated spectrum that would allow you to reach those. I mean, there is some TV white space spectrum that you might be able to get, and if you had you could set that up perhaps, but it's a lot easier to just piggyback off the GSM licenses if you can do a deal with the carrier, and then you've got they've got license to do spectrum that, I mean, the thing I've always loved about GSM is you can get 20 miles out of it, and that's possibly even more. So that you just, the range, the physical distance you can carry the signal on a lot of the kind of Wi-Fi type things, unless you've got a really directed antenna, it's down to hundreds of meters at the absolute maximum. So you can't cover big areas, whereas GSM is like built to do that.
I think that was a great application for cellular data because they've got the money to support it. Or like let's say you're Tesla Motors and you're building a cellular client into every single automobile, which they do for firmware updates and things like that. Not to mention like navigating and music and in vehicle entertainment. But so it actually makes me wonder about other specific vertical markets. Like I think about the fact that parking garages are often characterized by being sort of surrounded by concrete and steel, oftentimes underground. If the future of automobiles in this country and most countries is that they are all cellular clients, are there specific vertical markets, like for example underground parking garages, where you could come in and say basically we want to basically build sort of something like an enterprise private network so that your clients can their car can do firmware updates while it's while it's in the parking garage, or where, you know what I mean, like that's a kind of an absurd example in some sense, other than the fact that the both ends of the you have higher value products with but as just an example of a specific vertical market, besides like the enterprise wanting to run private voice networks, are there specific verticals that you can think of that are not voice related that might be able to stand on the shoulders of a network like this?
Who are you asking that question? Who's on the spot? Who's the spotlight go on?
Thought about it more than I have.
I haven't thought about. I mean, I haven't thought about it outside the context of voice so much. I think there are markets where I think the voice stuff is interesting, where you want the behavior to be different. Like if all you want is signal, then you probably just go out and get yourself a femtocell from one of the carriers. But if you want the behavior to be localized and different in some sense, then I think there are things that you might want to try and approach there. So, my favorite one is theaters. Basically, you stopping all incoming calls in the theater during the performance.
Oh, I see. By sort of forcing an association with a null access point.
Yeah, but outside that time it works. So you're giving a signal to people, and so you have a behavior that's around the locality. I think that's where
Gotcha.
Certainly for voice, I think that's a really interesting place to go. But whether there's money in it, I don't know. Anyway, I'm going to shut up now.
Also, the backhaul problem goes away.
And with that, as I turn my microphone on, we're going to go to the mature audiences only segment, and that means a little bit of music, and we're out of here. Thanks to Telestax for joining us again. Thanks to Ivelin, Bob, John from Range Networks, and of course Tim, Andy, James Bodie, who's out in the brush someplace. I don't know what he's doing, but he'll be with us hopefully next week. I forgot anybody? Of course, Michael Graves. And I'd like to thank myself, because I've had and it's time for me to thank myself.
Thanks, Randy.
Hey, that was the bleeding edge of the IP communications
Take care, guys.
and VoIP community. We're at vuc.me on the web. Thanks to simwood.com, who can turn you as a developer into a telco. Our hosted PBX is provided by onsip.com. The site at vuc.me is on bluehost.com. We use zipdx.com for our wideband, full-featured conference bridge. And our local rate dial-ins are from voxbone.com. Every Friday, 12 noon Eastern Time. See you next week.